Hello. So in this problem, we are provided with the differential equation, and we need to find a solution to this equation by using the method of variable separation. So let's begin. We will first rewrite this equation as 1 plus e raised to the power of negative x times tangent of y dx equals to x minus e raised to the power of negative x times secant squared y plus 1 dy. Now we are going to divide both sides by tangent of y times x minus e raised to the power of negative x. So that should give us 1 plus e raised to the power of negative x whole divided by x minus e raised to the power of negative x whole multiplied to dx, which is equals to secant squared y plus 1 whole divided by tangent of y dy. Now here we see that the coefficient of dx is purely a function of x and coefficient of dy is a function of y. Now we can integrate both sides. So let's begin with the integration on the left hand side. So here we can consider x minus e raised to the power of negative x is equals to t, and when we differentiate both sides we get 1 minus of minus e raised to the power of negative x whole multiplied to dx is equals to dt. So that means we will get dt divided by t, which is natural log of t, and since t is x minus e raised to the power of x, so this is going to be the value of our integral. And for the integral on the right hand side, so we can rewrite this as integral secant squared y over tangent of y dy plus integration. The 1 over 10y is simply cotangent of y dy. So integration of secant squared y over tangent of y. So if we make the substitution, tangent of y is equals to some variable u, then we get the numerator secant squared y dy upon differentiation. So that should give us natural log of tangent of y, and integration of cotangent of y is plus natural log of sine y plus the constant of integration. So we should get, therefore we will get, let's write it down, natural log of x minus e raised to the power of negative x equals to natural log of tangent of y plus natural log of sine y plus the constant of integration. So since everything is in log, so let's take the natural log of c, because c is a constant, so natural log of c is also going to be a constant, so that's not going to affect. Now we are going to use a property that natural log of a plus natural log of b is equals to log of ab. That holds for any kind of log, not necessarily a natural log. So we can write the terms on the right hand side, we can combine them to get tangent of y times sine y times c, and on the left hand side we have natural log of x minus e raised to the power of negative x. So we can take the anti-log on both sides, so we get x minus e raised to the power of negative x equals to c times tangent of y times sine y, and this is the required solution to the given differential equation.